Hello everyone, welcome back to my channel. I hope you guys are doing great. Have you ever wondered how Google Maps finds the fastest route, how LinkedIn shows your mutual connections, or how Amazon recommends products you are likely to buy? All these applications have one thing in common: they deal with connected data, and that is exactly where graph databases come in. Today, we will understand what a graph database is, why it is important, and how it is used in artificial intelligence. Before we dive into the concept, let us first understand why this topic matters. Most real world data is connected. People have friends, customers buy products, cities are connected by roads, doctors treat patients. When relationships become important, traditional databases are not always the best choice. This is where graph databases shine. So, what is a graph database? A graph database stores data as nodes and relationships instead of only rows and columns. Think of nodes as objects like people, products, or places. Relationships describe how those objects are connected, such as friends with, purchased, or located in. Imagine a social network. Each person is a node. The friendships between them are relationships. Instead of searching through multiple tables, the database simply follows these connections, making queries much faster. Now let us look at some real world examples. Google Maps uses connected roads to find the shortest route. LinkedIn uses relationships to show first, second, and third connections. Amazon recommends products based on what similar customers purchased. Banks use graph databases to detect fraud by identifying suspicious connections between accounts and transactions. Now let us compare graph databases with relational databases. Relational databases store data in tables and often require multiple joins. Graph databases store relationships directly, making them ideal for highly connected data. Both have their strengths, but graph databases are better when relationships are the focus. Now, let us connect this with AI. Artificial intelligence needs context to make better decisions. Graph databases provide that context by showing how different pieces of data are connected. In machine learning, these relationships help models discover hidden patterns, especially in recommendation systems and fraud detection. In deep learning, specialized models called graph neural networks learn directly from graph data. In generative AI and large language models, graph databases provide trusted knowledge that helps generate more accurate and reliable responses. Now, before we wrap up this video, let us go through some interview questions that are frequently asked. Here is question number one: what is a graph database? The answer is: a graph database stores data as nodes, relationships, and properties to efficiently manage connected information. Here is question number two: when should you use a graph database? The answer is: when relationships between data are more important than the individual records. Here is question number three: what is the difference between a relational database and a graph database? The answer is: relational databases use tables and joins, while graph databases store relationships directly. Here is question number four: name some real world applications of graph databases. The answer is: social networks, recommendation systems, fraud detection, route optimization, and healthcare. Here is question number five: how are graph databases useful in AI? The answer is: they help AI understand relationships, improving recommendations, reasoning, and decision making. Before we finish this video, let us quickly go over everything we learned today. We learned that graph databases are designed to store connected data using nodes and relationships. We also saw why they are faster for relationship based queries and how they power applications like Google Maps, LinkedIn, Amazon, and modern AI systems. Now you might be wondering where you will actually use this knowledge in your career. Graph databases are valuable for AI engineers, machine learning engineers, data scientists, generative AI engineers, and AI researchers. Understanding them also helps you answer common interview questions related to modern AI systems. So, the next time you receive a recommendation online or find the fastest route on a map, remember that a graph database may be working behind the scenes. Content page. Thank you so much for watching. If you found this video helpful, please like the video, subscribe to Learn AI with Jay, and share it with someone who is starting their AI journey. Also, let me know in the comments which AI topic you would like me to cover next. Thank you for watching, and I will see you in the next video.